This unit is going to be about probability, and we're going to talk about the normal distribution curve and how it relates to probability. However, we're going to be able to use a normal distribution curve. It is definitely bell-shaped, it's symmetrical. Right down the middle is basically represented by the mean. So the normal curve is a probability distribution with a total area under the curve of 1. We're going to get used to shading the total area, and the total area is going to relate to the probability. So since this is 1, we multiply it by 100, and how much of the area is shaded? 100%. These are the percentages highlighted that correspond to the area under the curve. If you will notice here in the dark blue, this area right here, which is symmetrical around the mean, represents 68% of the graph. So if that part is shaded, 68% of the graph is shaded. If we tack on this 13.6 and add that to 68, we'll get this number down here at the bottom, which is 95%. If we add on another 2.1% onto that, then we have 99.7% of the data shaded. Okay, so how does that work? Here, take a look right here. This is the mean. If we go over one standard deviation to the right and one to the left, we will be able to say that 68% of the data is represented by that interval. Take a look at the bottom. This right here is the notation for one standard deviation away from the mean, 2 standard deviations away from the mean, and 3 standard deviations away from the mean. Take a look at the other side. It's still 1 standard deviation away, 2 standard deviations away, and 3. The difference between the positives and the negatives is that the values are more than the mean, and on the left they are less than the mean. What we're going to do in this section, we're going to start to graph and show how a normal distribution correlates when we have actual real-time data. Okay, so we will always start off with a bell-shaped curve, and right smack in the middle will be our mean. This 0 is a z-score, and that z-score corresponds with the standard deviation. So here is 0. If I go to the right 1, I'm 1 standard deviation above the mean, 2 standard deviations above the mean, and 3 standard deviations above the mean. On the left side, -1, -2, and -3 all correspond to how many standard deviations it is from the mean. Now, the z-scores, you learned the formula in Algebra 1. We provide you with the formula here in Algebra 2, and we show you how to use it. When we find out that the data is normally distributed, we can convert it into a z-score. That will allow us to compare data values measured on different scales. So let's just say if you are in Algebra 2 Trig and your little sister is in Algebra 1 in middle school, and you both scored, let's say, an 88 on a test. Your parents want to know who's doing better in math. So basically, we'll be able to take the z-score, find out how the class did, the mean, and the standard deviation, compute it, and see who has a bigger z-score. And whoever has a bigger z-score is doing better in their math class. So I love z-scores. It allows us to measure on different scales. Okay, so what does a z-score do? A z-score allows us to see how many standard deviations above or below the mean of value is. So if it's positive z-score, it's above the mean. If it's a negative z-score, it'll be below the mean. So here we have the z-score formula. This will be provided for you. Here's the z-score. The x value here is the data that you're comparing. The test score, the quiz score, the pounds lost, or whatever it is. This represents the mean, and this is the notation for standard deviation. All right, here's our first problem. and we're going to make a drawing. It has a mean of 500. So right here, where we know normal will be 0, but for this particular data set, 500 will go here. It says it has a standard deviation of 100. So as I go 1 to the right, it's 1 when we're counting regular z-scores, but over here I add 100, and so my next value is 600. Here I go over 2, and that will correspond to 700. Go over 3 standard deviations, and that will correspond to 800. Over here to the left, go over -1, and that will be 400. Go over -2, and that will correspond to 300, and so forth and so on. So if a student scores a 700, what would be her z-score? Okay, so we can see, because we set our chart up, we can see that the 700 corresponds with the 2. So go ahead and take a look over here. 700 here goes with 2. But if we put it in the formula that's provided, z is equal to the value that we're trying to compare, 700 minus the mean over the standard deviation. And actually, what does that give us? 700 minus 500 is 200, and 200 over 100 is 2. So basically, we can see that it's 2 when we did our formula, and we can see that it's 2 when we shaded it on our graph. All right, so how does that translate? That actually translates to her z-score would be 2 standard deviations where? Above the mean. All right, reading through the question here, a set of math test scores has a mean of 70 and a standard deviation of 8. Set of English test scores has a mean of 74 and a standard deviation of 16. For which tests would a score of 78 have a higher standing? Let's see. You knew it was going to be math. Yay! So for this question, what will the miles per gallon for a Toyota Camry when the average miles per gallon is 23? It has a z value of 1.5 and a standard deviation of 5. How would we do this? All right, so the very first thing we would want to do is we would definitely want to write down our z-score formula. So we have that right here, and then we're going to put in our knowns into the formula. So this is a little different because it's giving us the z-score of 1.5, so we put that in place of z. X is what we're looking for, minus 23 over 2. When we solve it, we get x is equal to 26. So how does that translate? That translates to the Toyota Camry would be expected to use 26 miles per gallon of gasoline. We shall use a graphing calculator, and we're going to find the probability of events happening when we have the mean and the standard deviation. Okay, as we read through our first word problem, a calculus exam is given to 500 students. The scores have a normal distribution, that's our bell-shaped curve, with the mean of 78. Take a look, I have 78 right here at the center and a standard deviation of 5. So as you can see, it moves along this x-axis in increments of 5. On the inside, I did put in my normal z-scores that will correspond to the given mean and standard deviation. So here is 0, right here with the given mean, 1 standard deviation to the right is 83, and so forth and so on. So the question says, what percent of students have scores between 82 and 90? So I've shaded the area in question here. So to answer this question, we need to know what the area is. And once we find out what the area is, we will know the probability of students scoring between an 82 and a 90. But what we're going to do is we're going to do it on the calculator. So here goes. So here are the calculator instructions. You would go to your TI 83 or TI 84, and you'll hit second vars, DISTR, and you would go down to the normal CDF. So the syntax is going to be beginning to end, mean, and standard deviation, and hit enter. Okay, recap. So you're going to put it in the calculator, and you're always going to do lower bound, upper bound, mean, standard deviation. So if you take a look, So take a look again. We have our lower bound, 82. We got that from the problem. Upper bound, 90, because we're going from 82 to 90. And we put in the mean, which is 78, comma, standard deviation. And it spits out 0.20365. So we would change that into a percent, multiplying it by 100, and we would get 20.37%. So how do we say that? There's a 20.37% probability that a student scored between an 82 and a 90 on a calculus exam. You have to make sure you read the questions carefully because this here is a different question. This is asking how many students scored between 82 and 90. What we know is that there's a 20.37% chance that they'll score between that. But now that we know that it's 500, we're going to take 0.2037 and multiply it by 500, and we will see that there are about 102 students who scored between 82 and 90 on the calculus exam, and that's out of 500. All right, so we're going to get used to reading word problems, drawing a picture, and answering the question. So this is the same data set, but different questions. Now, this says the scores have a normal distribution with a mean of 78 and a standard deviation of 5. The question changes. What percent of students have scores above 60? So take a look at my graph. Okay, so if you take a look at it, I've shaded from 60 and above. And so that looks like the majority of the graph. Which part is missing that's not shaded? Oh, it's this part over here. So let's see how we're going to set this up in a calculator. We're going to definitely do that same vars, y-vars, distribution, and go to the normal CDF. And we're going to put it in lower bound, upper bound, mean, and standard deviation. Should look like this. With our calculators ready to go, we said the lower bound, which is 60, where we start. This 1e to the 99, you'll find the e key on the calculator. Down here it says 1e to the 99 is the far right of the graph. So this is a huge number in scientific notation. So it's from 60, I'd say, to infinity. And then the mean 78 and 5. As soon as you put that in, click, 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 you get out 0.9998. And so what does that mean? So there's a 99.98% chance that students have scored above a 60. Yay, glad to hear that. And also that corresponds to the percent of the area shaded under the curve. So it's 99.9% of the area shaded. So this is a different question. Make sure you read through it. This one says how many students have scores above 70. So we're going to change our lower bound, and so we're going to put a lower bound at 70. Our huge number right here, 1e 99. That's just like 1 times 10 raised to the 99 power. And it spits out 0.9452. Now it makes sense that 60% is larger because it's to the left of 70. So that makes sense. Well, here's a question over here. How many students have scored above 70? We would take the total that was given in the problem, 50, multiply by the probability we just found, and find out that 473 students have scores above 70 on the calculus exam. If you get a decimal, we can't cut students in half, so always round up. All right, so take a look at this question. This question here says find the probability of scoring below. This is important, below 1400 on the SAT. So when we start, because we're going below 1400, we're going to have to begin with a small value. So it's to the left of the graph. And so we're going to use negative 1e to the 99 power. And then we'll go to 1400, and then we'll put in the mean and the standard deviation and put it all in the calculator. This is the value that we get. So there's a 30.85% chance that a student will score below 1400 on the SAT.